If you work in IT or, frankly, if you just rely on a computer to do your job,
Which is pretty much everyone now.
exactly, just about everyone, you know that sudden sinking feeling.
Mm-hmm. The spinning wheel.
The spinning blue wheel, the system crash, that machine that just won't boot. You know, IT downtime, it isn't just annoying anymore.
Yeah.
It's a real threat to business, especially with so many people working remotely. And then there's the biggest threat of all, ransomware.
Right. And when we were looking at the sources for this deep dive, the numbers were, just stunning.
Unbelievable. Ransomware is costing the global economy upwards of $6 trillion a year.
That's not just a tech problem. That's a huge financial problem.
It absolutely is. And the sources we've got today, they focus on this automated endpoint recovery platform called Swimmage.
And it claims to offer, a complete shield against all that chaos.
Yeah.
So our mission for you, the listener, is to really unpack this thing.
Yeah.
A solution that says it can automate IT's most complex and stressful tasks. We're talking OS rebuilds, device migrations, full-on disaster recovery.
And the claims are big. Zero-touch, instant recovery, and this is the crucial 1-0 data loss.
It's a shift from just repairing things to actually designing cyber resilience from the ground up.
Exactly. So we're going to dissect how this single automated solution manages, repairs, and secures PCs no matter where they are.
In the office, remote, completely disconnected.
It's a bold promise. So, okay, let's dig into the core problems that make that promise so revolutionary to begin with.
Let's do it.
Let's start with the things that, keep IT leaders up at night. And we're not talking about simple password resets.
No, these are massive productivity killers. The sources really point to 4 big areas where IT just hemorrhages time and money.
So what's the first one?
First, you've got the simple catastrophic failure, the corrupted or non-bootable operating system.
Right, and traditionally that means hours on the phone, or worse.
Or the dreaded ship the laptop back to HQ. Then there's the second one, the delays in new hire provisioning.
Oh, I think we've all experienced that.
Yeah, a new employee can't start their job for 3 days because IT is still manually setting up their machine.
And the third point, which you touched on, is huge for remote companies. It's that challenge of device recovery in remote environments.
Precisely. If a remote worker's device crashes and they're on a slow, unstable VPN, trying to push a huge OS image over that is a non-starter.
You're back to shipping the PC.
They're back to shipping. And the fourth pain point is just the constant manual drag of compliance, checking every machine and forcing updates.
It all requires costly desk visits or these really time-intensive remote sessions. It just doesn't scale.
It completely breaks down.
So when we look at Swimmage's definition, how does it immediately stand out from, the traditional tools that try to solve these things?
Well, what's fascinating here is the emphasis on being self-healing. It's defined as an end-to-end automated solution.
Right.
Traditional imaging tools, they needed a strong network. They need a lot of manual effort to get them started and sort of babysit the process. This solution flips that. It's fully automated, it's self-healing, and critically, it can operate offline.
So the infrastructure basically repairs itself.
That's the idea.
And the speed claims are, they're genuinely shocking. We're told it can slash downtime by over 80%.
And for a crashed or infected PC, the claim is a rebuild in under 15 minutes.
A standard one is under 30. As someone who's waited hours just for a Windows update to finish,
Right.
the idea of a full OS rebuild being faster than making a coffee it's really disruptive.
It totally changes the cost-benefit analysis.
Yeah.
If your recovery time shrinks from days to minutes, the whole panic factor just drops.
It ensures business continuity. It makes the endpoints almost disposable in a good way. If it fails, it just rebuilds itself.
Exactly.
So let's talk about the architecture that makes that kind of scale possible. It's built around this 3-phase framework: detect, decide, and deploy. How does that flow?
That structure is really the intelligence of the system. So the detect phase isn't just waiting for an IT ticket. It's about policy-triggered rebuilds. The system proactively detects corruption or non-compliance or even just a scheduled migration. It knows when something is wrong based on company rules.
So it's not waiting for the user to report the problem. It kind of detects the sickness itself.
That's a good way to put it. Then it moves to decide. And this is where the intelligence really comes in. It uses AI-driven workflows.
So it's not just a one-size-fits-all image.
No, that's the old way. This dynamically decides the exact configuration, the apps, the security policies needed for that specific user on that specific hardware.
It's like bespoke automation.
At scale, yes. And then finally, deploy. That's the execution.
The rapid part.
Exactly. Deploy is where the system rebuilds the OS, restores all the apps, and this is key for security, enforces all the security protocols right there and then, all in minutes.
But the biggest game changer, especially now, has to be that offline capability. We talked about slow VPNs. If a device is totally disconnected, how can it possibly do a full rebuild?
Yeah, that seems impossible for a centralized tool.
Yeah.
But this is their unique architecture, designed for working anywhere.
Okay.
The sources really emphasize this offline deployment method. The key is that the system loads all the necessary files, configurations, drivers, everything, directly into a localized deployment kit on the device itself.
So the brain and all the recovery files are local. It doesn't need to pull gigs of data over a slow network to heal itself.
Precisely. And this is supported by some specialized components. There's a provisioning engine that acts as the local brain.
Right.
Then you have a driver interrogator. This is crucial. It instantly identifies the specific hardware.
Oh, so it avoids that classic problem of applying the wrong driver to the wrong machine.
You got it. That's a common failure point.
Yeah.
And the swim image conductor manages the whole workflow. This is the architecture that lets companies truly stop shipping PCs.
That makes sense. Okay, let's pivot that speed and architecture to the most urgent scenario. Ransomware.
The $6 trillion problem.
Yeah. If a machine is completely encrypted, how does this system eliminate that threat and restore the user instantly without data loss?
So what for a CISO here is the complete elimination of the threat vector. They call it swimmage rapid recovery.
Okay.
So when an attack is detected, the system isolates the machine and starts a full system rebuild.
Huh?
And it's very targeted. First, it removes the threats at the root. It's not just cleaning files. It wipes the infected OS environment clean.
And then it does that full system rebuild. We talked about OS, apps, data, all in minutes. But here's the critical question. How do we know the recovery point itself wasn't compromised before the recovery was triggered?
That is the perfect question. And that integrity is maintained through features they call Data Protect Snapshot and Data Protect Rollback.
So these aren't just standard backups.
No, they're snapshots designed to capture a secure, known good point in time. During the recovery, the system restores from that trusted baseline.
And it brings back the user's data, their profile, their settings.
Securely, during the process. So when the user logs back in, their machine looks exactly the way they left it. Only now it's clean, compliant, and secure.
And that preserves productivity. That's a very different conversation from just using cloud backups, which can take hours to restore, and then the user has to reconfigure everything.
Absolutely. And when we talk about trust, the whole thing is underpinned by a zero-trust architecture. And that isn't just a buzzword here.
What does it mean in this context?
It means the system ensures that the endpoint meets every single security, compliance, and health requirement before it's allowed back on the network.
Wait, can you elaborate on something you said? That data never leaves the device during recovery. That sounds like a huge security feature.
It is, and it addresses a major risk. In a lot of recovery processes, user data gets staged on a server or in the cloud temporarily.
Creating a vulnerability.
Exactly. The sources explicitly guarantee the data never leaves the device. It keeps everything inside the device's secure boundary, which is vital for things like HIPAA compliance.
That's a huge assurance.
Yeah.
And that speed of response completely changes disaster planning.
It really does. The CEO at one source noted that historically, companies often paid the ransom because their recovery timeline was just too long.
Right.
But with this, he says systems are rebuilt and restored to full functionality, usually within an hour. All data restored, all malware gone.
That's the difference between a minor incident and a company-ending disaster.
It is.
So, moving on from incident response, let's talk scale and regulation. The sources say this works for 100 endpoints or 100,000.
But for a big, regulated company, scale is nothing without compliance.
Sure.
And the sources highlight really robust compliance alignments. They mention SOC2, IPA, and FIPS alignment specifically.
And for our listener, why are their standards so hard to maintain during a system rebuild?
We'll take IPA in healthcare. Every device has to show continuous protection of patient data. This solution automatically enforces that during the rebuild.
So you're not left with a clean OS that's suddenly non-compliant.
Exactly. Same for finance, which needs strict audit trails. And FIPS alignment means it meets the security standards for sensitive government data.
So how does it do that?
The mechanism is that the system ensures every device enforces these protocols on every single reboot or recovery, providing a continuous audit log.
That continuous enforcement, it seems like it provides clear value to basically every stakeholder.
It really does. For CIOs and CISOs, it's strategic. It's cost savings, compliance, and eliminating downtime risk.
So they can focus on innovation, not just firefighting.
Right. For IT managers, the benefit is operational. They automate all these manual, repetitive tasks and save hours every week.
And for the InfoSec teams.
For them, it's continuous assurance. Every device that comes back online is enforcing the latest security policies. Period.
Before we wrap up, it's worth noting this isn't just about disaster recovery. We mentioned the Swimmage encryption converter.
Oh yeah, that solves an incredibly specific but very painful IT problem.
Tell us about that.
Migrating encryption types is, well, it's a nightmare. If you want to switch from, say, BitLocker to something else, you normally have to decrypt the whole drive, re-image, then re-encrypt.
That sounds like at least a full day of downtime per machine, plus a major security risk while it's decrypted.
That's it, exactly. The encryption converter eliminates that. It securely migrates the PC from one encryption type to another without re-imaging.
And without ever decrypting the data off the PC.
Critically, yes. The data stays encrypted the whole time. It's a massive time saver and security feature.
And they also offer white glove services.
Yeah, specialist support to guide companies through complex migrations and lifecycle management, so you get the tools plus the expert knowledge.
This whole deep dive has really shown us a fundamentally new approach to endpoint management.
I think so.
And the key takeaway for you, our learner, is this ability to get guaranteed, automated, zero-touch recovery in under 30 minutes. Whether that machine is in the office or totally disconnected.
That capability transforms the IT response from a scramble into a seamless, automated process.
For everything from a corrupted OS to a full-blown ransomware attack, it's moving beyond just fixing things to actually designing resilience into the infrastructure itself.
And if you connect that back to the bigger industry trends, this level of automation is really the foundation for a true zero-trust model in a distributed workforce.
How so?
By ensuring an endpoint has to constantly validate its own health and security before it can operate, you're effectively moving the security boundary right to the device itself.
That's a huge shift, from reactive firefighting to proactive design. So here's a provocative thought for you to consider.
Let's hear it.
Since this solution ensures that, quote, rebuilds automatically enforce company policies and systems can essentially self-heal, what does this automation mean for the traditional role of IT support?
Good question.
If the infrastructure literally self-heals and enforces its own compliance, are IT professionals moving away from being reactive fixers to becoming proactive architects? Architects who design and govern these intelligent, automated systems of resilience. It's a real question of skill set and focus that I think every IT leader needs to be asking right now. Something to mull over as you design your resilient enterprise.
We'll see you next time on The Deep Dive.